Today's lesson is all about review. We will be reviewing how to add and subtract mixed numbers. So I thought to start our review, we would review our 4 steps. Our first step is to rewrite the problem standing up. Second step is to check the denominators, and if they are not the same, we need to create equal fractions with the same denominator. We have a few strategies for that, and we'll talk about those in this review. Our third step is then to add or subtract based on the sign. We're only adding or subtracting our numerators once our denominators are the same. And our final step is to simplify or regroup, meaning we need to find out if the answer is greater than 1, and if it is, we need to regroup. And if it's not, we need to check to see if we can simplify by reducing the numerator and denominator by dividing, finding a divisor that will go into both the top and bottom number. So let's start off by reviewing how we find common denominators when we are trying to add or subtract fractions with unlike denominators. So I'd like you to try to stay a step ahead of me on here in figuring out what our new denominators are. I've taught you basically 3 ways to find common denominators. The system we're going to use with these 3 fractions should be the same system for all of them. And this would be the first thing I would do when I'm trying to find a common denominator. So let's take a look at our first fraction over here. 9/14 and 2/7. So step 1, rewrite the problem. That's done. Step 2, checking the denominators to see if they are common already. We can see that our denominators are not common. So the first thing I would do would be to take a look at my largest denominator, which out of these 2 denominators is 14, and ask myself if I were to use 14 as a common denominator. Of course, it's going to work for this fraction because we know there's always a multiple. That would be 1. But will it work for the other fraction? Is there a multiple, a number you can multiply to 7 to get 14? And yes, there is. So in this case, looking at the largest denominator to use as your common denominator will work. We would fill in our numbers and find our new numerators, and then we would go ahead and subtract those. Now let's take a look at the second fraction. See if you can find a common denominator in the second fraction that will work. Again, the very first thing I would look at would be my largest denominator, which in this case is 28. And I would ask myself, if I use 28, again, we know it was going to work for this fraction, but would it work for the fraction below? Turns out there is a number you can multiply to 4 to get 28, and that number is 7. So as long as it works for this, I'm using my largest denominator, the one that already exists. What this is going to do for you is it's going to allow you to use the smallest common denominator. And that's always helpful, as I've mentioned before, in the last step where you're simplifying or regrouping. If you've used the smallest common denominator, you're going to find that you have less work to do. On the last fraction, we're going through the same steps. We're going to take a look at our 2 denominators that we have already, and we're going to look at our largest one and ask ourselves if we could use that. And of course, we know it's going to work for the top fraction, but will it work for the bottom one? And it turns out it will. We can multiply 3 times 6 to get 18. Do the same thing to the top, and we'll get 6. The top fraction is going to stay the same. One thing that you should be noticing already is that when you're using the largest denominator, that the 2 fractions that you end up with are the same. You can see 9/14 and 9/14 there. Here we use 28 as our common denominator. So 3/28 is equal to 3/28. We can't change the numerator on these because the denominators are the same. The fractions have to be equal. And then the only way to make an equal fraction with the same denominator would be to include the same numerator. Not to mention the fact that our multiples, if we were to go ahead and do this properly, our multiples would be times 1, and you would end up with the same numbers. So you can see that that is one of the benefits of using the largest number as a common denominator. On these next group of fractions, we're also going to be looking for common denominators. So we're going through these steps again. We rewrote the problem. We're now checking for common denominators. We see that we have two denominators that are not the same. And now we need to find an approach to find common denominators. So we're looking at 12 as our largest denominator, and we're asking ourselves if we can use 12. Since there is no number that we can multiply 8 by to get 12, 12 is not going to work for us. So now we need to come up with another strategy. The strategy I would like to use would be to take the 12 and start thinking of multiples of 12, and as we go through our multiples of 12, ask ourselves if it's also a multiple of 8. Since 12 is not a multiple of 8, we're going to go to 12 times 2, which is 24. 24 is a multiple of 8. We can find a multiplier that would equal 24. That would be 3. So 24 would be our lowest common denominator, sometimes known as LCM, lowest common multiple. So 24 should be the one that we use. When finishing this problem, we would have to do the same thing to the top fraction, times 3. That would get us 15 24s. And on the bottom, our multiplier would be times 2, and that would get us 2, and then we could subtract our problems and get 13 24s. And our last step would be to check for simplifying or regrouping, none of which can be done here. This is not improper, and it cannot be simplified. In taking a look at our second example, again, we're looking for a common denominator, preferably the lowest common multiple of our two fractions. We look at our largest fraction first. That would be the best strategy, to use 6 if it's possible. But is there a number you can multiply to 4 to get 6? 4 times 2 is 8, so that's already not going to work. So in keeping with my strategy, one of my strategies is going to be to take our largest denominator and start writing out or thinking of the multiples of 6, looking for the first multiple of 6 that 4 will go into. 4 will not go into 6 evenly, so the next multiple is 12, and 4 will go into 12. So this assures us that we're finding the lowest common multiple, and our denominator will be as small as possible. And our multiples, of course, won't be as easy to figure out. We'll have to figure them out. It'll be 4 times 3 and 3 times 3. And here would be times 2 and times 2. And now we can subtract and get 1/12. Our final step is to check to see if it can be simplified or if it's improper. We're subtracting here, so it won't be improper. And it cannot be simplified because our numerator is a 1, which is prime, and you only have one unit, so you can't simplify that. Now let's look at our final example in this group of fractions where we're still looking for a common denominator. And we'll begin as we normally do by looking at the largest denominator, 45, and seeing if we could use that. And since 30 times 2 is 60, that's not going to work. 45 will not work. So in keeping in line with my strategy I've been using on the last 3 fractions, we're going to take our largest fraction, which is 45, and we're going to find the next multiple of 45. 45 times 2, which is 90. We can just simply add that in our heads or on paper. And we can find out that 45 times 2 is 90. And will 30 go into 90? And you can kind of tell that it will. If you know some things about dividing, you know you can cancel off like zeros. So you know that 3 will go into 9, therefore 30 will go into 90. So again, recall the strategy we're using, which is taking our largest denominator and finding multiples of it until we find one that works. Our first multiple that works will be called our least common multiple, and that will be the best denominator to use. So here now we must finish this by multiplying the bottom by 2 here and by 2 on top to get us 32. By 3 here and by 3 on top to get us 33. We're adding these two fractions together, and we get 65 over 90. 65 over 90 can be simplified. It can be. We can simplify this fraction by dividing both the top and bottom number by 5. 5 goes into every number that ends in a 5 or a 0. And here 5 will go into 65 13 times. 5 goes into 6 one time with 3 left over. That 1 will go in front of the 5. That will be 5 going into 15 3 times. 5 goes into 90. Well, it goes into 9 one time with 4 left over. And it goes into 40 8 times. So 13 over 18, which is our final simplified answer. Please remember the focus on this particular group of fractions was on how to find a common denominator when you couldn't use the largest denominator that already existed. My strategy then was to take that large denominator and find the next multiples of it until I could find the first one that could be used. Our next set of fractions will also have unlike denominators, and we will use a third strategy in order to find common denominators. The third strategy I'm going to show you is one that works every single time, one that you're really quite familiar with, and that is simply multiplying the two denominators you see. My first trick would always be to look at the 10 to see if my largest denominator would work, and certainly you could utilize my second technique, which would be to find the common multiples of 10, which the next one would be 20, which 3 does not fit into, or 30. However, in this group of fractions, we're just going to multiply our denominators to find a common denominator. Why this isn't always the best method of finding a common denominator, because it doesn't always give you the smallest one. It is one that will always work, so you shouldn't have to spend a lot of time trying to come up with a common denominator. If you find yourself spending a lot of time, just multiply them. So on our first fraction, our common denominator is 30. Our multiple down here will be 10. 10 on the top as well will get us 20. Our multiple here would be 3, and 9 times 3 is 27. Then we will subtract our fractions, get 7/30. And our second group of fractions, our second fractions here, we're going to look at our two denominators and find a common denominator by multiplying them again. In this case, 20 will be our common denominator, and in which case, if you were to use strategy number 2, which is find your multiples of 5, you would see that by multiplying these two numbers, we're getting the smallest possible denominator anyways. Another clue that you may just be able to multiply the denominators is when you have small denominators. A small denominator like 4 means that it's likely you're going to end up multiplying them anyways. You probably won't find a smaller one. It's not always the case, but when you have small denominators, it's likely you'll be able to find a common denominator quickly, either by multiplying or working out the multiples. We'll finish this one up here. Our multiple on the top would be 5 times 4. 3 times 4 is 12. And our bottom one would be times 5, and 3 times 5 is 15. One of the great things about using our two existing denominators is that we know what our multiples are going to be. There's no guesswork involved. If we take a look at our last fraction, we're multiplying 9 times 7, which is 63. Guessing what the multiple is going to be is quite simple. There is no guessing. We use these two numbers to multiply together to get 63. So 7 times 9 is 63, and 9 times 7 is 63. Our multiples are quite easy to remember when we're using our existing denominators. And here would be times 7, which is 14. So multiplying the two denominators will always get you a common denominator that will work, but it won't always be the best denominator. If you do not use the lowest common denominator, you will have to simplify, and simplifying or regrouping should be a common thing that you ask yourself after you finish every problem, regardless of whether or not you even knew that you found the best denominator. It should just be standard practice. We'll finish these problems quickly here before we end our lesson. 12 plus 15 is 27 over 20. And step 4 says simplify or regroup this problem. We're going to regroup this problem because it is equal to more than 1. 20 will go into 27 one time with 7 left over out of 20. That would be our final answers. You cannot simplify 7/20ths. And in our final fraction, we're adding together 14 and 9, and we'll get 23 over 63. This is a more difficult problem to simplify. It is not improper, but the question becomes, can we simplify? And knowing your rules for numbers will help you here. Looking at 23, if you're not sure if you can simplify, always look at your smallest number and find out what numbers will go into 23. And I'll do that up here above. 23 would be 1 and 23, and no other numbers. 23 is a prime number that only has 2 factors. Therefore, unless 23 will go into 63, you cannot simplify. 23 will not go into 63. Therefore, we are finished. And we are finished for today's lesson. Move on with the rest of your morning work.